Yeah.
Thanks. I hope you're able to see the screen.
Yes.
Okay. So hello everyone. Let me welcome you all again. A bit of introduction from my side. So this is Varsha from Bits.io. I'm working in Splunk for more than 7 years now. Today we will talk about risk-based alerting and how we can enhance security operations with it. Let's look at the agenda. So we will start with an overview of risk-based alerting, its benefits and importance, key differences with traditional alerting, and how RBA works, its core components, the RBA methodology, how is this related with a Splunk enterprise security, followed by a short RBA demo, and ending the session with some key use cases and best practices and suggestions. So let's start with the overview of risk-based alerting. So basically, risk-based alerting in Splunk, like it's a powerful approach to enhance the security operations by reducing the alert fatigues, prioritizing critical threats, and providing the contextual visibility. So we will see in the demo as well, like it will correlate the events and provide you the contextual information. It shifts the focus from traditional rule-based alerts to a system that scores and correlates risky behaviors over time and enables the better decision making. To refresh, we can say that RBA focuses on connected behavior made out of the data, giving us contextualized security stories of behavior and observation rather than generating individual alerts like the traditional alerting system does. So it correlates the related events, aggregates them into high fidelity alerts based on calculated risk scores. That's an important terminology in the risk-based alerting system. So it reduces the noise and improves the operational efficiency. Moving on to the benefits and importance. So since risk-based alerting prioritizes alerts based on risk scores, which helps in reducing the alert volume with increase in alert fidelity. It's not like we are getting less alerts, but ultimately we are looking at so much more because we are embracing this noise. We are getting so many more observations and just alerting on it in a more intelligent manner. It detects low and slow attacks by correlating events over extended time frames. Truly operationalized with the wonderful MITRE attack framework, CIS, critical security controls, the kill chain, or we could create our own framework, like customize it, depending on whatever interesting security metadata we want to apply to these individual data events. We call risky events. With the help of risk-based alerting, investigations went from taking days to minutes and more time for the SOC to pursue high-value activities like threat hunting and content engagement. It improves visibility and provides many frameworks to support threat hunting as well. Moving on to the key differences. So in many aspects, it is better than the traditional alerting system. For example, the traditional alerting generates individual events for every detection, while risk-based alerting aggregates events, correlates them into a single risk notable. Where the traditional alerting generates high volume of alerts, often overwhelming the analyst, the risk-based alerting reduces the alert volume with high fidelity. It also provides contextual information, unlike the limited contextual data, unlike the limited contextual data from the traditional alerting, and it focuses on behavioral patterns over time rather than point in time detections. In risk-based alerting, we are getting a holistic view of related events. Like we are getting this correlated events and so on. But in traditional alerting, we are required to put the pieces together and from the multiple alerts that are generated manually. And sometimes they also have like multiple SOC people, a team, different individuals working on separate alerts, which are correlated, but traditional alerting won't let us know that. And in different point of time, different point in time, these individuals are looking at these alerts, not able to correlate them and not able to figure out whether the alert is a false positive or it's really important. Um, any questions so far regarding the basics? Okay.
No, actually.
Okay. Let's move on to the next slide. So, why organizations need the RBA? With the increasing complexities of cyber threats and expanding attack surfaces, traditional alerting is no longer sufficient. Challenges being the SOC teams face alert fatigue from managing thousands of alerts daily, most of which are false positive. They also struggle with contextual blind spots as isolated alerts lack necessary context and time consuming investigations, which requires manual correlation. Now, risk based alerting enables a proactive, risk focused approach, helping the analyst detect and respond to meaningful threats, let's say, very efficiently. It supports organizations in shifting from reactive to proactive strategies by embracing the automation and machine learning, facilitating advanced hunting and strengthening the overall security posture. Basically, it lays a flexible foundation for SOCs. Let's look at this example. So we are looking at different events generated over a time frame of 10 days. On March 2nd, an email was sent to the competitor domain. On 7th of March, user activity during abnormal hours were observed. On 8th of March, high number of files were downloaded from the shared drive. On the same day, these files activity there were observed a file activity to USB devices, like something was getting returned to the USB devices. On 12th of March, user filed 2-week notice. Here, the risk object is the user. So when using the traditional alerting system, separate events, these events would be generating separate alerts, which would not make sense. Let's assume that these alerts are being received by separate individuals from a SOC team. These analysts are looking at these alerts being generated and may not feel that they are risky events and consider them false positives or something like that. However, in the risk-based alerting system, we are tagging these alerts, tagging these risky events with a risk score like 15, 25, and 40 points to each of these events, and calculating a aggregative risk score, which is 130. We will be applying a risk incident rule, which is only a notable alert would be generated in case the aggregated risk score is greater than the threshold. Let's say we have a threshold of 100 in 30-day period. So 130 is exceeding that particular threshold. And after the condition is satisfied, like this risk incident rule this criteria is met, an alert would be generated with immediately relevant context for investigation. Any questions on this?
So we can
How
encourage. I mean, so here you are looking only for a week or 2 weeks. Tuesday to more than 2 weeks, right?
Yeah.
March 2nd to March 12th.
Yeah.
So I also wanted to know, how are we coming up with these risk score? Are we doing this based on a matrix or?
No, risk score basically it is dependent on your organization or environment, policies. So let's say we can start, if we are not aware of it, we can create a risk score. Let's say we can assume a risk score of 10, and based on the criticality. For example, you have a risk object as a user. So a normal employee is a user, like he would not be that risky component, like that risky object, but a user with admin privileges is a higher, is at risk, is at higher risk. So we will associate some higher risk score with a user as admin. So, we will be defining it based on the environment policies, based on the organization rules and policies. Another example would be, let's say, you have an IP address, but if it is internal within the intranet, it's fine. If it is an external facing IP, that would be higher, that would be at higher risk. So we would be calculating the risk score based on these, like these priorities as well. I hope that answers the question. It's not something that is defined in a matrix, but we need to calculate it based on the criticality of any asset, any risk object.
Okay, thank you, Varsha.
Yeah,
Venkatesh, if
also,
you want to add anything?
yeah. Also, we can define the risk score, based on the, is it a server or is it a, user? We can define that the risk score. We will show once, Varsha shows the demo environment, like how we can define the risk score for a particular, user or a particular service. For example, like if the CEOs or CEO laptops is more concerned, right? If any phishing is happening on that particular email, we need to make sure the risk score for those users or for those servers would be high, right? We can define those things. So we will show you that once the demo environment comes up.
Yep.
Thanks.
Yep.
That's
Thank you.
Thank you, Venkatesh, for adding that. Yeah. So, this was how RBA would act. Unfortunately, in the traditional alerting systems, like alerting volumes are overwhelming SOCs anyway. So, as an example, the SIM might generate 3 separate alerts, and each of those alerts is probably assigned to different security analysts in a different point of time, right? So in this case, each analyst would be looking at one event in a string of activities and dismiss the notable. None of the analysts would have the full context of the notable in case of traditional alerting systems. And two things will be happening here. Each analyst gets too many low-level alerts, which miss the bigger picture, and alert fatigue sets in as they burn out, working the same, mostly benign, low-fidelity events. So traditional alerting triggers alerts based on predefined conditions applied on the data source, which can result in overwhelming alert volumes. While risk-based alerting focuses on the risk of an event over time. How it works is, in this, it uses the Splunk's detection logic and provides an observation. Here tags that observation with security metadata like the log source, attack tactic, and a score, risk score, then dynamically modifies the risk score based on interesting attributes of the observed object. So, such as whether it involves a privileged user, an asset priority is there, if there is a critical vulnerability count, if there is a BU outlier. So based on these factors also, we can modify the risk score. So alerting will happen when there are enough interesting observations correlated to the same object. Until then, risk-based alerting doesn't send any notable to an analyst. Now, all these risky events are stored in the risk index here, which then triggers only a high fidelity alert. In any analyst here, like based on the risk incident rule, it will trigger a high fidelity alert. So any analyst can still see all those risky events collected in the index. We will look at how it will display the events. So basically, the risk-based alerting will catch all the complex behaviors over various time periods versus point-in-time alerting. Some important terminologies. So risk event generation. We already saw like what is risk index. It is where the risky events are getting stored, and the analyst can further use it to check all the events that might contribute to a potential threat. Now, risk event generation. Events with potential threats are tagged with risk score and risk metadata. Example, we may tag it with some MITRE attack tactics, source type, source, etc. Risk scoring is basically, it reflects the severity or importance of an event based on the, for example, any privileged account or critical systems, or if it is a contractor user, the risk score may vary. Now, all the risky events are stored in the risk index, providing a unified repository for monitoring and analysis. Now, how do we calculate the risk score? So it is calculated by multiplying the rule impact number with the rule confidence number and a modifier factor based on the risk modifier count. Now, how do we find out what are these numbers? So we need to ask this question. If this event is malicious, how bad the damage is? Based on the answer, we will be defining the rule impact number. Like what is the impact? Then based on the domain knowledge, how likely is this a malicious event? How confident you are based on the historical effectiveness? Like if it is a critical vulnerability, or if it is a critical asset, if it is an internet facing asset. So that is the confidence number. And the risk modifier count, we need to see if it is a critical, based on the criticality on of the entity. So system or user, etc. Any questions so far? Okay, let's look at how the risk notables are generated. So the risk-based alerting uses the existing Splunk enterprise security correlation rule framework. It will be using the dashboards as well from the enterprise security framework. And what it will do is basically, with the help of correlation searches, we will be looking at a demo as well. We will be basically modifying the existing correlation searches to trigger a notable event response action. And these response actions are written in the notable index. Now, after getting written onto the notable index, these will also be viewed on the incident review dashboard. Security analyst investigates the notable events on the secure incident review dashboard from the ES framework, and they may change the review status of the notable event to track the progress. When we will be looking at the demo, maybe it will become more clear to you guys. So yeah, let's move forward. Sorry, any questions on this? Okay. Implementing the risk-based alerting. So it uses a risk-based alerting methodology, which is an iterative process that helps organizations adopt and refine the risk-based alerting over time. Like it's an iterative process. So it is structured into 4 levels: quick start, development, operationalize, and production. Level 1 is all about getting familiar with how the risk-based alerting works. It will use the default in the Splunk ES environment to start with, and then it will monitor and tune those correlation searches and rules to produce high fidelity alerts. Level 2 is the classic development stage. Whatever was learned in level 1 can help to monitor and modify the existing rules and correlation searches to produce higher, by setting up, sorry, yeah. So it to improve the risk rules for higher fidelity alerts and curate the risk notables. Level 3 will prepare your RBA implementation for production by setting up the dashboards, which are useful and required. And it will also modify the existing case management processes to be more effective with RBA. Level 4 is basically the time to go live. So it is in production. RBA is in production in your organization, and it carefully monitors activity and results, fine-tuning the rules and processes as needed. So keep improving, as in it is, since these levels are like iterative process, so we will keep on improving the rules and modify the object severity, the risk scores, and based on that we will achieve finally, like not finally, we will keep on improving basically. So yeah, the stage that we desire. These are few core components of a risk framework. So risk rules basically are logics, we can say correlation searches, to identify potential risky behaviors. The risk index is a central repository to aggregate and store the risk events. Then dynamic risk scoring is assigning every object, risky objects, with some scores based on the priority. And risk incident rules basically aggregate risk events into actionable risk notables. Like what is if the score is greater than the threshold, it will generate a notable risk. Let's look at this example. So let's see an attacker is trying various techniques on a single server over time. So in this case, 3 different alerts that use different factors here and time scales to look for threat behavior would be observed. So score threshold 100 exceeded over 24 hours, events from multiple source types over 3 days, and multiple MITRE attack tactics observed over 7 days. So these are few alerts which would be triggered in this scenario. So here, since we are utilizing the MITRE attack framework, these are the tactics in the MITRE attack which will be associated with the kind of alert. For example, if it is a non-standard port activity, this is the source, and this is the tactic which is tagged with it, and we have a score for the same. Similarly, for potential C2 activity, new registry startup key and new scheduled task is created, we have a score based on the tactic from MITRE attack framework. Initially, when we are not aware of what score to be used, the ES framework and the ES, since we will be using ES for risk based alerting implementation, and we can also utilize the MITRE attack frameworks and other frameworks, CIS, etc. We can understand what scores can be given based on the tactics. We can read more about it online. So yeah. One second. Yeah. Moving on to the next slide. So what are the expectations and goals like for implementation of risk-based alerting? Initially, we may temporarily see increased amount of alert volumes during the testing phase, which would require also a lot of investment in understanding if they are false positives or not. It would also require analyst trainings and tuning, and it would need iterative refinement to align with the environment, like we have seen with the 4 levels in the previous slides. But it does offer long-term benefits, like 50 to 90% reduction in alert volumes, faster incident investigations, higher fidelity, actionable alerts. The RBA uses Splunk Enterprise Security, and it is a required for implementing the RBA. Basically, these are the core components which RBA would be using. So risk analysis, adaptive response action. We will see these all components in the demo environment as well. Notable events, asset and identity framework, the common information model and data models, and the risk analysis and risk event timeline dashboards from the ES. Let's look at the small demo. But any questions till now, if you have? Okay. So since RBA would be using the enterprise security, we have already we already have this enterprise security app, and we will be using the dashboards and the features from the ES app itself. To start with, we will be looking at the correlation searches, which we can get from the content management here, content management. So these are some correlation searches already present, and we can create based on our requirement. So when we edit any of the correlation search, let's take as example of brute force access behavior detected. Here we will be tagging that particular correlation search with a MITRE ATT&CK framework or kill chain or CIS20. We can do that based on our requirement. Basically, if you want to modify uh, based on any other framework like kill chain and CIS2, you can also do that. So I have added, we have added this MITRE ATT&CK T1110 and T1201. We can refer to the matrix here, the MITRE ATT&CK matrix. It will tell you about these environments and what are the tactics based on, what are the tactics and techniques which represent the MITRE ATT&CK for enterprise. So back to the content management here, the correlation search. What we will do is first we have added the annotations. Then we will add a adaptive response actions. Here you will see adaptive response action for, since I have already added it, it will not show. So we have an adaptive response action for risk analysis. So basically here, we will have multiple entities. So multiple entities in your correlation search. So in your, maybe you're searching for something related to user, something related to source, destination, or IP addresses. So these are your risky objects. These could be your risky objects. And there can be multiple risk modifiers. So we ensure that for all the objects, we are adding some risk score. So for my risk object source, I have added a risk score of 80, which is of the system type. The source is a system. Another user object, risk object, I have added a risk score of 20. So based on the correlation search here, if I have used any user here or any app here or any source here, I will be, for that particular risky object, I will be creating and adding a risk score. So any questions, like what, any questions so far? This again, risk score is defined on the priority of like what are policies of my organization, or it will vary company to company. So yeah. There is one more thing I wanted to show is risk factor editor here. So for example, this risk factor editor will allow you to fine tune the risk scores based on the environmental specific policies. For example, if my user is admin, so since the admin, for the admin user, the risk will be higher because it will have some privileged accesses. So what I have done is I have multiplied a factor of 1.5 to the existing risk score of the user. So if this score of the user is 10, it will be multiplied by 1.5, and the risk score for admin user would be 15 in that case. So risk factor editor in the enterprise security here will help you configure and fine tune the risk scores for different objects. Another example is we have added here 5. 5 is being added to the user if he is a contractor. Why we are doing it? Because contractors may present additional risk due to different personal security controls. So we have added a factor of 5 if the user is contractor. Here, by using these risk factors effectively, we can be sure that we are pointing the analyst, the SOC team, to the most important events based on the organization's need. So I hope that answers the question that was asked by you. Uh, Sorry. Yeah. So you
Yes,
can have different risk scores.
it
So
it did
uh,
answer the question. Thank you.
yeah, you can have different risk scores, but based on the criticality of the risk object, you can modify the risk factor and here on the risk factor editor UI. So again, back to the correlation search, we can also generate a notable here. It can be informational. You can basically the SOC team can, for them, we can create the informational notables so that they can still investigate them in the incident review dashboard. So if you're already familiar with the enterprise security, you know where we can see the notables in the incident review dashboard here. So these are few notables generated. Now, after I have modified the correlation search here and saved the contents added, I will be able to see the notables raised or triggered for that particular correlation searches, for which I have already associated the MITRE attack annotations, the risk analysis adaptation response action, and the notables also, that information notables as well. So if we see here, if we go to risk notable, apply, I'll be able to see some risky events and the risk notables which were triggered for those correlation searches that I have modified. Let's look at this example. 24-hour risk threshold exceeded for system, this Lenovo system. So here the risk object is the Windows system. It has a risk score, aggregated risk score of 120. We can also look at the risky events which triggered this notable. So when I click on the risk events, I'll be able to see what time, the timeline basically here, this risk message, the risk rule that was applicable, the risk score, which gives us a aggregated score of 120, and any annotations. So here, if we see, there are these MITRE attack annotations being assigned to these particular risky event. So the risk event would be is basically discovers anomalous activity such as deletion or clearing of log files. It seems risky, hence we have hence the system has generated some risky notables. It will help you look at the timeline here. So in case we have multiple events, you can adjust the timeline and look at all the events which are which basically are triggering this risk notable. Yeah, it also will show you the urgency status. You can assign it to any particular owner if you want to, and there is an action drop down based on the options available here. You can proceed further for the same. Next is since these risk notables are generated, you can look at these events in the risk index here. So if I see, if I check for last 15 minutes or 60 minutes based on the requirement, which will make more sense, like which time frame should I analyze? So I can look at the data which is being aggregated to the risk index. It will, looking at this data, it will help you become more familiar with the annotations that are being built. So for example, these are the annotations of the MITRE attack frameworks and the other frameworks. We will be getting more idea about it. We can also have a look on the risk objects here. So for example, this email ID is a risky component, like it's a risky object with a count of 69 over the last 4 hours. The SOC team can look at it and analyze more about the risky events around this particular object. We have these different IPs. So if you think like out of these, only one IP is more risky, you can look at that particular IP and analyze the logs around the same. We can also check which MITRE technique is associated with these risk objects. So based on the events in the risk index, you can look at what is what annotations and what techniques are being associated with these particular risky events and objects. The enterprise security offers some built-in aggregation rules as well, some built-in correlation searches. So yeah, we can have a look at that, but given the time, yeah, we can look at it later, or maybe we can spin up a test environment and check it. Yeah, like this is as much as I can show you on the demo environment, but yeah, any questions on this?
No, sure.
Okay, so moving back to the slides. There are many use cases and for the risk-based alerting. Here are a few key use cases which can be used for the same. So the machine learning, risk-based alerting enhances machine learning by generating context-rich data sets. So we can not just limit risk-based alerting to provide high-fidelity alerts. We can also use the system of risk-based alerting to generate some context-rich data sets for security from the security logs. And it can be fed to the machine learning environment and help in various other use cases. Like it would be very of high value use cases as well. Insider risk. So it streamlines insider threat detection, reducing noise, and building an efficient program with fewer data sources and quicker detection. Also, RBA helps in detecting the account takeover and fraudulent activities from new accounts by leveraging the Splunk app for fraud analytics, improving fraud detection accuracy. Best practices and tips. So the first one is reduce noise early. We can continuously tune risk rules to eliminate the irrelevant alerts and improve the signal to noise ratio. We can also implement a variety of risk rules across multiple data sources so that we can capture, different types of threat for threat huntings. Um, we can we can basically use different frameworks like MITRE ATT&CK we saw, and CIS and asset prioritization to enhance the context and accuracy of the alerts. It will provide you more contextual information with the help of these frameworks. So we can implement and leverage those frameworks. We can treat RBA as an ongoing process. So it will continuously refine, if we keep on continuously refining the risk rules, risk scoring, and incident response workflows, it will be really helpful for the organization. Engage teams early, which would really mean that we need to involve the analyst, red/blue teams, and stakeholders early to shape the effective detection strategies and if responses we need to automate. So that would be all for the session today. Thank you so much for following along, and thank you for joining. Do you have any questions? Like, does anyone have any question?